So if we look at all the forces acting on the incline, we have a table normal, a weight, the force that's pushing, and this incline plane force reaction from 1 onto 2. Now to get the angle, we need to think about the geometry here. The angle with the table is theta, so then the angle to the vertical is theta, and the angle to the vertical then would be right here between force normal 1 on 2 and the weight. Now mass 1 is on an inclined plane. There's a gravitational force, but the acceleration is to the right. So we don't want to rotate the axis, because rotating the axis is to put the acceleration in one dimension so we can sum our forces. So summing the forces in the x direction on the wedge shape, so M2A, so there is a force push external, and then there is a component of the normal force from 1 on 2, but it's the sine component, and that is going to cause M2 to have an acceleration. In the y direction, there is a balance of forces, so the normal from the table minus the gravitational force minus the component of the normal from 1 on 2, and that component's the cosine component, would equal 0. So now over here, we need to sum the forces in the x direction, because M1 is going to accelerate in the horizontal direction. We need to sum the forces in the horizontal direction. So there is a normal force component from 2 on 1 in the x direction. That's the sine component. Summing the forces in the y direction, 0, because it's balanced. So you have the component of the normal force from 2 on 1 and the weight of 1. Now we're going to do some algebra. So the physics is over and the algebra begins. So if I see the sine and cosine equations up here. So if I take my sine equation and then the forces in the y direction with the cosine, and you know FG is equal to mg, so I multiply that out, then I can reduce that equation to being the sine over cosine's tangent, and m1a over mg is just a over g. So then the acceleration of our system is just g tan theta. Now the net force on the system would be the push on the whole big thing. So the force push would equal the sum of the masses of the system times the acceleration of the system. Now the acceleration of each object is equal to the acceleration of the system. So the pushing force would equal, now the mass of the system is m1 plus m2, and my acceleration is g tan theta from earlier, and that's it.